Morning students, I welcome you all to a new class in physics today. Children, as you all know that we have already finished with the theory for chapter 1, that is force. In today's class we will be focusing on the numerical problems of exercise 1A, which deal with torque and principle of moments. Okay, so I read out the first question to you. The moment of force of 10 newtons about a fixed point O is 5 Newton meter. So here they have said that a force of 10 newtons is applied and the moment of force is 5 Newton meter. You are supposed to calculate the distance at which the force will be applied. So it's very simple. We use the formula of torque, F into D. We substitute the values of torque and force which is known to us, and we can calculate the value of D using, dividing 5 by 10, and that works out to 0.5 meters. Let's move on to the next numerical problem, children. It has been given in this question that a nut is opened by a wrench of length 10 centimeters and the force applied is 5 newtons. When the force is in newtons, the distance has to be in meters. So divided by 100, 0.1 meters. You're supposed to find out the moment of force. Simply we'll use the formula F into D and substitute the values and work out the answer, which is 0.5 Newton meter. The third numerical problem is supported by a diagram. Here the diagram is given to you. You can see that it is mentioned it's a wheel of diameter 2 meters from the one end to the other. That's the diameter 2 meters. A force of 2 newtons is applied at one end. You are supposed to find out the torque about point O, which is the midpoint, and about point A, which is towards the other end. First of all, when we need to find out the moment of force about point O, we are using the formula F into D. You can all see that the force is 2 newtons, but what about D till point O? The distance till point O will be only 1 meters. So, it will be 2 into 1, that is 2 Newton meter. And see the direction, children. It is going to be clockwise. Okay, you have to mention the direction even if not asked. And the second point is you are supposed to find out the moment of force about point A. Again we are going to use the formula F into D. F is 2 newtons and D till point A will be 2. So that will be 4 Newton meter clockwise. I hope it's understood. Let's move to the fourth numerical problem. It is again supported with the diagram over here. You can see there are 2 points, 2 ends of the rod A and B, and it is pivoted at O. One distance OA is 2 meters and the other is OB 4 meters. Force of 5 newtons is applied at end A and force of 3 newtons is applied at end B. Now what is expected of you? You are supposed to calculate the moment of force F1 about O. So naturally F1, you are supposed to find out the moment of force about F1 at about O due to F1. That will be F1 into D, that is 5 newtons into 2 meters, that is 10 Newton meter, and you can see the direction would be anti-clockwise from left to right. Then we move on to the second part of the question. It says again you are supposed to find out the moment of force, and it is about point O by F2. So naturally we'll take F2 into D. That will be 3 newtons into 4 meter, that will be 12 Newton meter, but this time the direction would be clockwise. Okay, see, you are supposed to be very careful about giving the correct direction. Then they have asked you to find out the total moment of force. Total moment of force naturally would be anti-clockwise positive, so I have taken 10. Clockwise we know the sign convention negative, so I have taken minus 12. The overall answer would be minus 2 Newton meter, but we will not represent it in negative. We would rather say that it is 2 Newton meter clockwise. It is understood clockwise is negative. I hope you have understood it. Let's move on to the fifth numerical problem, children. In the fifth numerical problem, I am reading it out what is, okay, they have given you the diagram again. Here you can see it's a couple applied at the ends of the rod AB. The couple, because the force of 10 Newton each is applied at the ends, and the total length of the rod is 4 meters. And you can see they haven't given, but you know that it is going to complement each other and the rod is going to move clockwise, right? You're supposed to find out the, what have they asked you to find out? They are supposed to find out the resultant moment of force about the pivot point. Now, because it's a couple, we can say either force into the couple arm. What is the force? 10 Newton. What is the total couple arm length? 4 meters. So that will be 40 Newton meters. And as you can see that they are complementing, so it will be clockwise. Right? So this is the fifth numerical problem. Now we go to the sixth numerical problem. In the sixth numerical problem, it has been given over here. A diagram again is given. You have been shown that there is a force applied, or a force of 10 newtons applied at A. Force of 10 newtons is applied at point B, and they are, this particular thing is pivoted at O. And you can see because they are again complementing forces to equal opposite parallel forces, we can see that the system is going to move clockwise. And the distance between A and B is given to be 50 centimeters. Now the question is divided into three parts. The first part is you are supposed to find out the resultant of both the forces about point A. Now first of all, resultant of both the forces about point A. Listen very carefully. About point A, children, you can see that this force is at 0 perpendicular distance because it is lying along the axis. So naturally it would be 10 into 0. And the other force is at a distance of 50 centimeters from A. See, this force is along the line of action of A, so it will be 10 into 0. Perpendicular distance is 0, but the other force is at a distance of 50 centimeters. So that will be 10 into 50 upon 100 because this is in centimeters. We need to convert to meters. When we add the two, see, this becomes 0, but this would be 5. So the overall resultant is 5 Newton meter and clockwise. Now we go to the second part of the question. It says you are supposed to again find out the resultant about point B. Now about point B, if you see, this particular force is along the line of action of B. So again it will be 10 into 0. But what about this force? It is at a distance of 50. So it will be 10 into 0 plus 10 into 50 upon 100. And it works out to 5 Newton meter clockwise once again. And about point O, you are supposed to find out the resultant moment about point O. Again about point O, children, the resultant would be the 10 Newton force. This force is about point O is at a distance of 25. And the other force is also at a distance of 25. So 25 centimeters each. So it will be 10 Newton into 25 upon 100 plus 10 Newton into 25 upon 100. That would be 2.5 Newton meter plus 2.5 Newton meter. And it works out to 5 Newton meter clockwise. Okay, so remember about point O, one force is 0 while the other is at a distance of 50. Similarly for point B also, one force would be 0 acting along the axis. The other would be at a distance of 50, and about point O, it will be each force would be at a distance of 25 centimeters each. Okay, now after this particular question, we move on to the seventh question, seventh numerical. In the seventh numerical, you are supposed to draw the diagram. The information is given. There is a steering wheel of a car having a diameter of 0.5 meters. Now you can see I have drawn the steering wheel and the diameter to be 0.5. They have said that two forces are acting, 5 Newton each force is acting and rotating the wheel anti-clockwise. Now you have to be very careful. Anti-clockwise means you have to show the direction of the force in such a manner that it would turn the steering anti-clockwise. Okay, so one would be directed, of course the forces would be applied at the two ends. One would be directed downwards, the other would be directed upwards, and they will turn the wheel anti-clockwise. You can see. Okay, now you are supposed to find out the moment of force applied. So that would be F into D. E the force, that is 5 newtons, into the total perpendicular distance 0.5 meters, and that is 2.5 Newton meter anti-clockwise. Okay, understood? Now we go to the eighth question. In the eighth question, they have given you have a uniform meter rule. Now you will draw the uniform meter rule, represent it from 0 to 100 centimeters. We know when it is a meter rule, it is from 0 to 100 centimeters, and the CG is at 50 centimeters. It is assumed that the CG is to be at 50. Okay, what else is given? And you know, CG is a point where the weight of the rule will act downwards. Okay, and it has been given that you have a 50 GF weight suspended from one end. Now one end could be either 0 mark or 100 centimeter mark. It's up to you. I have chosen to put 50 GF on the 0 mark. Okay, now the question is, they have said that where should 100 GF be suspended? Naturally, common sense, when 50 is suspended at one end, the 100 GF should be suspended on the other end. Okay, in order to counterbalance the 50 GF, right? I hope you are understanding. If 50 is on the LHS, 100 GF should be on the RHS, but they are asking you where should it be suspended. So we will use the principle of moments over here. That is the sum of anticlockwise moment is equal to sum of clockwise moment. The formula says W1 L1 is equal to W2 L2. What is W1, children? 50 GF into what is L1? The distance from the pivot, that is 50 centimeters, is equal to 100 GF where? So it will into L2. We are supposed to find out the value of L2. So L2 will be 50 into 50 upon 100. When we work out, it is 25 centimeters. But you have to clearly mention the side. So it is 25 centimeters on RHS. Had you just mentioned 25, it is understood that it is on the LHS because it starts from 0. So you have to mention 25 centimeters on RHS side, or you could also say that this is if this is at 50 and you add 25 to it, so it becomes at 75 centimeter mark. So this is also the correct way to represent your answer. Okay, so now we move on to the 9th numerical problem, children. In the 9th numerical problem, it has again been given to you. The information has been provided. You have to draw the diagram. It is given that is a uniform meter rule. So 0 to 100, CG 50, weight of the rule, right? And it is mentioned that it is pivoted at 58 centimeter mark. I have shown the pivot here. It is knife edged. This is the knife edge at 58 centimeters, right? And they have also mentioned that a weight of 20 GF is hung from one end. Now you may be wondering, why have I shown 20 GF at 100? Why not at 0? To understand that, let me use this pen of mine. If I place my pen at 58, children, just check, because it is the knife edge is at 58. Now you can see already there is a weight on the LHS, right? So if I put the 20 GF again here at 0, there will be two weights on LHS. Then what will counterbalance them? So therefore, it is understood that if one weight of the rule is on the left hand side, naturally the 20 GF should be on the RHS. So that's why I have taken 20 GF on 100 centimeter mark. Understood? Now they have asked you in the question to draw the diagram. We have drawn it, and you are supposed to find out the weight of the rule, right? Using the principle of moments, sum of anticlockwise moment is equal to sum of clockwise moments. W1 L1 is equal to W2 L2. Now what is W1? We don't know, weight of rule. What is L1? Yes, now this is important. L1 would be the distance of the suspended weight from the pivot point. Okay, weight from the pivot. So that is 58 minus 50. Okay, and what is W2? 20 GF. And what is the distance between this suspended weight and pivot? 100 minus 58. I work out 21 into 8 is 20 into 42. When it is solved, the weight of the rule comes out to be 105 GF here. Okay. Now the last question for this particular section, 10th question, the diagram is given to you. In the diagram, it's again a meter rule, but it is divided 50 divisions on LHS, 50 divisions on RHS, and 10, 20, 30 moving outwards on both sides. It has been given that a 40 GF is suspended at 40 mark. Question says, where should a 80 GF be suspended? Again, we know that when 40 is suspended on the LHS, 80 will be suspended on the RHS to counterbalance it. So using principle of moments, sum of anticlockwise moments is equal to sum of clockwise moments. W1 L1 is equal to W2 L2. What is W1? 40 GF. What is L1? Again, it is 40 from the pivot, right? So 40 into 40 is equal to 80 into the length to be found out, and solved. When solved, it works out to 20 centimeters. You have to clearly mention the 20 centimeters should be on the RHS side. Okay. So with this, we end 10 numericals. Now I'm going to record the remaining numericals in the next video. Thank you, children. Just go through them.